Northern Iowa, heart of the Corn Belt, a land blessed by nature, a land of fertile soil, deep, rich loam that rolls easily from the moldboard, a land of tall corn whose heavy golden ears pile up fast in the wagon box, lush alfalfa to fill haymow and silo with high-protein winter feed, soybeans ripening in the autumn sun, their pods bursting with plump seeds, dairy cows waiting patiently for the evening milking, beef cattle, slick and stocky, future steaks and roasts for America's dinner tables, hogs, long, lean meat types, always hungry, future hams and bacon to please the housewife. Yes, this is the Corn Belt, blessed by nature. Blessed, too, by the industrious and progressive farm people using up-to-date machinery and modern farm methods. To make their work easier, faster, more efficient, electric power comes to them on these distribution lines along the straight roads. High-voltage transmission lines cut across fields and vault streams. Where do these lines come from? What is the source of the energy they carry? Here, just below the forks of the Des Moines River, a few miles from Humboldt, is the first steam generating plant of Corn Belt Power. 80 miles to the northwest, near Spencer, is the new Earl F. Wisdom steam generating plant, completed in 1960. These two modern plants are the major sources of energy for the Corn Belt system. This system stretches over 28 counties in northern Iowa. It serves over 30,000 farmers through 13 farmer-owned rural electric cooperatives. Over 950 miles of 115,000 and 69,000 volt transmission lines reach every part of the area. 8 diesel plants provide additional power for emergencies and peak loads. 55 step-down substations reduce transmission line voltages at load centers for the distribution lines of member cooperatives. The whole system is tied together so that every distribution cooperative has two-way feed. An interruption of service here will not affect an entire local system because by looping, the interruption will be limited to this small area. Interconnections with 13 municipal systems, 2 major utilities, and the U.S. Bureau of Reclamation provide for interchange of power to balance demand and generation throughout the Corn Belt area. In addition, Corn Belt membership in the Iowa Power Pool provides for quick and efficient exchange of power on a statewide basis. Interconnections between the Iowa Pool and generating systems in other states make it possible to get emergency help in either direction between Iowa systems and major generating systems anywhere in the United States. The entire Corn Belt system has one purpose: to provide farmers with an adequate continuous supply of electricity. Electricity is a farm necessity today. It means better, more efficient farm operations. Electricity is the modern farmer's most valuable hired hand. Electricity milks the cows faster, enabling the farmer to handle larger herds. It cools the milk quickly to protect its quality and thus assure a better market price. It means healthier pigs, a faster start towards that 1-ton litter 5 months from now. And more eggs because electricity provides more hours for feeding in the poultry house. Electricity mixes the feed, pumps the water for the livestock. It elevates the bales of hay and unloads the silo at the turn of a switch. Electricity takes the toil and backache out of cleaning the barn. In the farmhouse, electricity banishes the drudgery of the farm wife. Electric kitchens are clean and efficient. Electricity puts fresh, wholesome food on the table. It eliminates the back-breaking, time-consuming labor of doing the family wash. It provides hot and cold running water for every household use. It brings entertainment and education into the farmer's living room. Electricity means a higher standard of living for the farm family, makes a farmer a better customer for the products of American industry. When the farmer has more money to spend, there is more business on Main Street. For every dollar invested in generating stations, transmission and distribution lines, the farmer spends $4 for electrical appliances and machinery. Children enjoy their farm work more because of electricity. Electricity helps to keep them on the farm. 4-H and FFA competition at the county fair shows that farm boys and girls look forward to farming as a livelihood. They are learning to raise better livestock, to use better farm methods, because they want to be better farmers in years to come. It's a great feeling to win that blue ribbon. Electricity means more leisure time. Dad and Mom can really enjoy the fair. For each one, there's something of special interest. For Mom, it's a chance of winning a prize on home canned fruits or vegetables. And for Dad, it's the horse races. Rural industries in many localities are made possible only because power at reasonable rates is made available by rural electric cooperatives. This drying and pelleting plant provides a steady market for soil-building alfalfa and turns the alfalfa into high-protein winter feed. At Hubbard, this corn drying plant provides a valuable service for the farmers of the area. On a farm near Britt is another corn drying operation. 10 fans, each driven by a 5-horse motor, force air through ducts to dry the corn. Approximately 40,000 bushels will be in this pile. This fertilizer plant near Humboldt is a significant addition to the business life of the community. The Corn Belt system has brought other benefits to the area. More than 300 Corn Belt and member cooperative employees are substantial citizens and homeowners in their communities. Their wages alone add $1,800,000 annually to their community's income. Over $310,000 in taxes each year are paid by the member cooperatives of the Corn Belt system. Corn Belt itself paid $534,000 in property taxes for 1961. The loans from REA that enabled the farmers to build their electric lines are being repaid on or ahead of schedule with interest. Similarly, Corn Belt Power Cooperative is making repayments on its REA loans far ahead of schedule. The directors of Corn Belt, one from each member cooperative, have good reason to be proud of the progress their organization has made. They have watched Corn Belt grow from just an idea to a substantial business owned by and serving over 30,000 farmers. In the beginning, before Corn Belt was started, only 14 out of every 100 Iowa farmers had central station electric service. Now practically every farm is hooked up. Iowa farmers are near the top in the nation in their use of electricity. Corn Belt farmers can well remember when farm chores meant long hours of manual labor. Even then, they realized they must have electricity to make the farm more efficient and a better place to live. They had been unable to get electricity from private power companies, so they met together to find out what they could do through cooperative action. Aided by county agents and local Farm Bureau leaders, they organized their own county electric cooperatives. Loans from REA enabled them to build distribution lines, but these lines were useless without electricity at a price farmers could afford to pay. So they organized 2 generating cooperatives and built 2 diesel plants. This one at Hampton, built by Federated Cooperative Power Association, was energized in March 1938, one of the first REA-financed cooperative plants in the United States to go into operation. This station at Pocahontas, built by Central Electric Federated Cooperative, went into operation in May 1938. A 3-phase tie line between the 2 plants provided for exchange of power between the 2 generating cooperatives. Farm use of electricity was limited at first to simple lighting and a few small appliances. The 2 plants easily supplied all the energy needed. Farmers soon found out that electricity is their best and cheapest hired hand, so they added electric milkers, pump jacks, and other labor-saving appliances. By 1942, the demands of wartime production had doubled initial farm use of electric power. Generating capacity could not keep up. Farmers were urged to turn their yard lights off and limit their use of electricity in other ways. Electricity on some lines was cut off 15 minutes at a time so the plants could carry peak loads. Near the end of the war, it was possible to begin construction of several new plants. 8 additional diesel plants were built and put into operation by the end of 1948. Directors of both generating cooperatives realized the urgent need for an integrated system with one base load plant and a high voltage transmission network. A merger of the two systems was the logical answer. Finally, in 1947, the two organizations were merged. Corn Belt Power Cooperative was born. REA approved a loan for a new steam plant at Humboldt, 300 miles of transmission line, and necessary substations to start an integrated system. October 1950. A great celebration marked the completion of the new Humboldt plant. Farmers and townspeople gathered to see the fulfillment of years of planning and effort. They toured their new plant to see for themselves what a modern generating plant is like and how it operates. Let's find out what they learned. Coal and gas are the fuels used in the Humboldt steam plant. Coal arrives by rail and is dumped into the hopper under the tracks. A conveyor belt elevates it into the transfer tower. Here, the coal may be moved directly to the bunkers located over the boilers inside the plant or diverted to the stockpile. At both Humboldt and Wisdom, gas is more economical than coal. When coal is used, from 600 to 700 tons are needed every day. There are 2 sources of water, the river and 2 deep wells. Well water for the boilers is pumped into this tank. But before it can be used, it must be analyzed for mineral content and purified to prevent scale and corrosion inside the boilers and turbines. Regular checks are made of the water in the boilers as well as of new water to be added. River water is used to condense the steam. When all units are running, there is need for 61,000 gallons per minute. A cooling tower provides for lowering the temperature of the water before it returns to the river so it will not raise river temperature more than 10 degrees. The steam, when it leaves the boiler, has a temperature of 910 degrees and a pressure of 800 pounds per square inch. Steam entering the turbine rotates the shaft, which in turn rotates the generator, thus creating electricity. Sounds complicated, doesn't it? Well, it is. So let's illustrate with a schematic drawing. Coal or gas in the furnace, here, provides intense heat for the boiler, here, which produces steam. Steam pressure against the turbine blades, like wind against the vanes of a windmill, causes the shaft to turn at 3,600 revolutions per minute. When the steam has done its work, it passes into the condenser here, where it is cooled by the river water passing through these tubes. The steam condenses into water, which is recirculated to the boiler to be turned into steam once again. Additional purified water is supplied through this pipe to make up for small losses of water in the steam flow cycle. The shaft connecting the turbine and the generator turns the attached electromagnets in the generator so that they cause an electric current to flow through the coil windings fastened to the generator housing. From the generator terminal, the electricity at 4,160 or 13,800 volts passes to the transformer, where it is stepped up to 69,000 volts. All this from boiler to transformer takes place in a fraction of a second. The entire process begins when the operator starts the turbine by opening a valve. When the turbine is up to speed, the system supervisor synchronizes the generator with the system, and electricity starts its journey at the speed of light to every corner of the system. Every step of the process is under control. Trained men know precisely what is happening all the time and what to do in any emergency. Good housekeeping, spick and span cleanliness keeps that new look, fosters good maintenance, and promotes safety. When repairs are needed, a fully equipped machine shop manned by a competent maintenance crew assures prompt attention to the job at hand. A giant crane operating through the roof hatches can lift and move heavy machinery parts wherever required. The control room at Humboldt is the nerve center of the whole system. It observes and directs every change in generation and transmission. System supervisors are on duty every hour of the day and night. They keep in touch with every corner of the system by means of a microwave main communications highway, into which are fed carrier phone, two-way radio and telephone messages, as well as signals to and from the supervisory equipment at Humboldt to operate all units and interconnections. The system supervisor must anticipate and plan for the power use of our members 24 hours or more in advance. When planning has been completed, the supervisor communicates by teletype with other members of the Iowa Power Pool. They buy and sell power, just as shares are bought and sold on the stock exchange, in such a way as to assure all customers of ample power at lowest possible cost. It is now necessary to decide what units to operate in Corn Belt system. This modern load control equipment automatically controls the operation of the steam units at Humboldt and Wisdom, and continuously loads the units for best possible efficiency. If emergency help is needed by Corn Belt or any other system, this control unit automatically loads or unloads the generating units or interconnections. It also continuously checks Corn Belt's interconnections to see that everything is going as planned. Thus, farmers are assured of adequate power for the next 24 hours. Everything must be carefully planned according to weather and other conditions. Operation of too many units increases expense. Too few means shortage of power. Sometimes an emergency calls for special attention. Thus, if a switch opens even 100 miles away, the supervisor knows it immediately and can close it at once. The System Control Office is the clearinghouse for line crews and requests for special help.
Corn Belt truck number 8 calling Humboldt Control.
Go ahead, Corn Belt 8.
There's an insulator broken on pole number 269, 2.5 miles west of the Emmitsburg sub. Could we take the Emmitsburg Ayrshire line out of service so we can replace it?
No, we're just going into the noon peak. We can't release the line now. Besides, a storm is moving in from the northwest. We'll call the transmission superintendent to send the hotline crew right away. Will you stand by until they come?
Okay.
Humboldt Control calling Corn Belt 14.
Corn Belt 14, go ahead.
Truck number 8 reports a broken insulator on pole 269, 2.5 miles west of Emmitsburg. We can't release the line now. We're just going into the noon peak.
10-4, I'll send the hotline tools right up. We'll have them there in about an hour.
The hotline crew is used to emergency calls. They have to be ready to go whenever and wherever there's trouble. These men are trained to do an important job quickly, carefully. They are skilled in the use of special tools for hotline work. Here's where training really counts. One slip, one misjudgment could mean a serious accident, even death. There it is, the new insulator in place. A job well done without interruption of service to the farmers on the line.
Humboldt, this is truck number 8.
Go ahead, truck 8.
We've replaced the broken insulator on pole 269.
That was fast work, number 8. Any snow yet?
Not yet, but the wind's coming up, and we'll be at the Emmitsburg sub if you need us.
10-4.
Corn Belt number 8, clear.
Day in, day out, in all kinds of weather, these men keep the lines hot. thus assuring maximum service to all the farms of the Corn Belt. The farmers depend on this kind of service. It is more necessary now than ever before because with every passing year, electricity plays a bigger part in farm operations. The all-electric farm is already here. It is no longer just a dream of the future. The farm of tomorrow is fast taking shape under our eyes, where more things will be done better because of electric power. Irrigation from electric pumps will provide water for thirsty crops. No more need to depend on fickle nature. Crop drying will aid the farmer to get more food value from his hay and other feed crops. Human lifting and carrying will make way for automatic electric choring. Even the hens will be assured a constant and adequate supply of feed with a minimum of human labor. Many farm homes already have safe, efficient electric heat in the winter and electric air conditioning during the hot summer. Even cooking is being simplified and shortened by the use of electronic ovens. Hungry? No need to wait long. This roast took only 15 minutes. All these changes in farm living have been a challenge to the men who guide and manage Corn Belt. They have planned years ahead for constant improvement in facilities and equipment. Year by year, their plans take shape in steel and concrete. Thus, in 1958, in the midst of a field near Spencer, excavation was started for a new generating plant. Less than 2 years later, the new Earl F. Wisdom plant was completed. In May 1960, the first 33,000 kilowatt unit went into operation. This plant combines modern design and engineering know-how to give greatest possible efficiency. It operates at 800-pound steam pressure and 910 degrees superheat. And it employs the latest techniques in burning powdered coal. One man at the control console can observe and control the operation and efficiency of the entire plant. In the meantime, the U.S. Bureau of Reclamation allocated power for Corn Belt from the great hydro plants on the Missouri River. Construction was begun on the high-voltage transmission lines and substation to bring Bureau power to the Wisdom plant. Back at Humboldt, construction was started on new headquarters buildings on Highway 169. It was a proud day for Corn Belt members and employees when their new home was finished. This modern, electrically heated and cooled building provides space for constantly enlarging operations, ample room for the steady growth that is sure to come in future years. The dreams and plans of the pioneers are a practical reality today. The network of electric lines serving over 30,000 farms is the realization of their vision and determination. What they have built must be used and expanded to provide greater service in years to come, to be a heritage for future generations. Corn Belt Power Cooperative is and will continue to be a symbol of greater opportunity and a better life now and in the future.